This video is more of a how-to of going between different number bases. Again, decimal is base 10, and so we never write that because decimal is the most common system. But if we had something in base 2 or binary, then we would use this to designate the number base. So this is binary, and to go from binary to decimal, we need to remember that just as in the decimal system, where each position designates a power of the base, so in decimal we have ones, tens, and hundreds. In base 2, we've got powers of 2, and the ones digit is always 1 for reasons that you'll learn later. It is the 0 power of 2, and that's 1. So then the next place, just as in base 10, it's this next place that is tens, and these are 2s, 4s, 8s, and 16s. Now binary is kind of nice because either you have 1 or you have none. So in base 2, if we want to translate this, well, if we're reading the value of this number, then this is 116, no 8s, 4, no 2s, and a 1. This is the number 21 in decimal. So that's going from binary to decimal. That's just my autofocus dot. Going the other direction, so if I wanted to take, let's say, 60 in decimal, and I want to express that in base 2, notice how my base 2 or binary number is made up of these different parts. Well, I'm going to look for what parts I need, or what powers of 2 I need to make up the number 60. And so I'll just list out those powers of 2. And notice I don't have 64 because I only need 60. So my first one, I'm going to have 32. Well, what's left in my number? Well, I'm going to subtract 32 from 60, which is 28, so I will definitely need a 16. Again, base 2 is nice because I'm either going to have 1 or none. I don't need to worry about how many. So then I have 12 left, which means I have an 8 and a 4. And then I'm done. I have no 2s and no 1s. And so in binary, this is going to be the number 111100. That has the value of 60. Now it might help to look at it again this way and see that this is indeed 60. So I've got no 1s, no 2s, I have a 4 and an 8 for 12, a 16 for 28, a 32, and that adds up to 60.